Now I can introduce next speaker, Marko. Please, you can share your slides.
May I begin?
Yes, you can start.
Thanks. Greetings, dear colleagues. I am happy to be here, and I am happy that the colleagues from Kiev and Odessa are able, in such a difficult time, to make such a great collection of people meet at, even if it is of in online premises, to meet and discuss maths despite such horridity happening just some couple hundred kilometers away. So today I would like to present on recent findings that I myself and Mr. Lahutik have investigated on the semigroup of injective monoid endomorphisms, a some extension of the bicyclic semigroup. So, following the semigroup topology posited by Lawson in his book of 1998, I believe it was Semigroups, the theory of monoids. Yes. By omega, we denote the set of all non-negative integers. Let P of omega be such a family of all subsets of omega. For any F family that belongs to P of omega and any integer n, we posit that n summed with F is n plus k with any k that belongs to F, if F is a non-null subset, and n plus an empty subset is an empty subset. A subfamily of F is included in P of omega is called omega close if there exists such a subset F1 in intersection with subset minus n plus F2 that belongs to that subfamily for all n that belong to omega, and F1, F2 belong to F. For any A that belongs to omega, we denote A is defined as X that belongs to omega, and each X is greater than A. On the set B omega, that is equal a product of omega on itself, we define a semigroup operation that is equal to basically multiplication in the following way. It is well known that the bicyclic monoid is isomorphic to the semigroup B of omega. The following construction was introduced in Gutek and Mikhailovich work of 2020. Let F be an omega closed subfamily of P omega. On the set B omega product with F, we define the semigroup operation in the following way, as we can see. Also in Gutek and Mikhailovich works, it is proved that if family F belongs to P of omega and is closed, is omega closed, then a pair of B of such product B omega and F, and the defined operation is a semigroup. Moreover, if an omega closed family F that belongs to P omega contains the empty set, then the set I is an ideal of semigroup that we have defined. For any omega closed family F that belongs to P omega, the following semigroup is also defined in the first article. In paper 2, that is Gutik and Poznikova publishing of 2022 on monoid semigroups. Injective endomorphism of the semigroup BF of omega with two-element family F of inductive and non-empty subset of omega are studied. Here the authors describe the elements of the semigroup and of B omega of F of all injective monoid endomorphism of the monoid B omega of F, and show that Green's relations R, L, H, D, and J on and of endomorphism of B omega of F coincide with the relation of equality. As per paper of Gutik Poznikova 2023, and yet I believe an unreleased paper of Gutik Poznikova of 2024, the semigroup and endomorphism of B omega of F of all monoid endomorphism of the monoid B omega of F is studied. An example, let f to the power 3 equal such a set of 0, 1, and 2, fixing an arbitrary positive integer k, we can define a transformation alpha of k of the semigroup of B omega of F to the power 3 in the following way, as we can see. For all E and J that belong to omega. From this, we posited a lemma that for an arbitrary positive integer k, the transformation alpha of k on that is on the mapping of B omega of F3 to B omega of F3 is an injective monoid endomorphism of the semigroup B omega of F3. The theorem was that let F3 be such a set of 3 elements as defined, and epsilon be an injective monoid endomorphism of the semigroup of B omega up to F3, then epsilon equals alpha of k for some certain positive integer of k. By a set of natural numbers and an operation, we denote the multiplicative semigroup of positive integers, and from that we also posit that let such a group F3 contain 3 elements, and then the monoid endomorphism B omega of F3 of all injective endomorphism of the semigroup B omega of F3 is isomorphic to such a semigroup. This is the citations, and thanks for listening to my talk. And thanks to everyone that is defending us in this hard and uncertain time.